11.4 irrational square roots. Now, you know what? I mentioned this in yesterday's lesson, and I want to talk about it some more. And SK, I think you'll realize and recognize that this is the stuff that that the little sheet that you handed me was about. I can't remember where you got it, but anyway, that's what we're talking about. But guys, remember, anytime you have radicals, you can multiply them, as long as they're the same root. So let me talk about that for a second. This is the, I'm sorry, hang on. You could have the square root of 16, right? That equals 4. You could have the cube root of 27. That's 3. You could have the fourth root of 81. That's also 3. You could have the fifth root of 32. That equals 2. Now, what do these things mean? That means that this number, cubed, is equal to 27. This number to the fourth is equal to 81. This number to the fifth is equal to 32, right? So when I have something like this means what number multiplied by itself 6 times equals the stuff that's in here, right? Now, as long as the roots are the same, and that's what we're going to be working with. We're going to be working with square roots, okay? So we don't have that to worry about. But as long as the square roots are the same, right? I mean, as long as the roots are both square roots or both cube roots or both, fourth roots or whatever, I can multiply them. So let's say I've got the square root of 2 times the square root of 8. Okay, well that means, or these two things are equal to the square root of 16, which is equal to 4. Okay. Also, okay, if I have the square root of 15, right? If I can multiply them, that means I can factor them too. Square root of 15 is equal to square root of 3 times square root of 5. That's true. Okay. All right. That's cool. Now, this is an idea that we need to use when we're simplifying radicals that don't come out to a nice, pretty whole number, right? Root 16, that comes out to 4, right? But root 17 does not, right? So sometimes we're going to get some radicals that are irrational. They don't come out to a rational whole number, okay? So what we're going to do is we're going to simplify them the way we would reduce a fraction. Same idea. Whenever I can simplify a radical, I need to simplify the radical, okay? So here we go. Example number 1 says simplify root 28. Well, here's all you need to do. This is very simple, okay? You will remember prime factoring, all right? You want to prime factor root 28, and that's going to be root 2 times root 14, right? Now this one's done. Now prime factor this, root 2 times root 7. Okay, now that's done and that's done. I can't break them down anymore. So I've got root 2 times root 2 times root 7. Well, remember we talked about this yesterday. I don't know if you remember, but root 2 times root 2 is equal to 2. Now let me go back through that again. Root 2 times root 2, do you agree that that equals root 4? And root 4 is 2. Anytime I multiply a square root by itself, I get the number that's underneath. So when I'm simplifying, I look for pairs of radicals. These two things just turn into 2. This is 2 root 7. Now, I'm going to pull out my calculator here. And you should pull out yours too, okay? So you'll see that root 28 does equal 2 times the square root of 7. Let's do that. All right, so square root 28 is equal to, approximately, right? Because remember, it's irrational. 5.291502622. Okay? And when I come down here, I'm going to get 2 times, I should do that in a different color, just so we know. This is our answer. Okay? And this is going to be 2 times, what's the square root of 7? The square root of 7 is equal to 2.645751311. And then when I multiply that by 2, I'm going to get 5.291502622. Right? The same thing. Okay? Does everybody see that? I can reduce this because it has a perfect square that goes into it. Right? The square root of 4 goes into the square root of 28. And the square root of 4 is 2. Okay? So we take that out. We simplify that part and we're left with square root 7. Okay, let's look at the next one. I hope I made that clear. I think I did. All right, let's look at the next one. All right. Example number 3 says simplify the square root of 432. I have no idea what this is. And I don't mean to. I don't need to guess a perfect square root that goes into that. Just prime factor. Root 2 times, what is that? Root 216, I think. Okay, now this one's done. This is definitely root 2 times root 108. That's done. 108, I'm going to do root 9 times root 12. Okay, let's keep breaking that down. Uh-oh. There we go. This is root 3 times root 3. They're both done. Okay, you'll see that'll turn into 3. This is going to be root 2 times root 6. And then this is going to be root 2 times root 3. All right. It looks like we've simplified it as much as we can. There's nothing else to break down. So now let's write our prime factorization. Okay. Uh-oh. Lost it again. Okay. So I've got root 2 times root 2 times root 2. Write them in order because it'll help organize it for you. Times root 2. Times root 3. Times root 3. Times root 3. Okay. That looks like everything. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So I've got all I need there. Remember, a pair of roots, a pair of square roots turn into the number underneath it. So that's 2 times, right? 2 times 3 times root 3. I don't have a pair for that one. Oh, that's all. 2 times 2 is 4, times 3 is 12, times the square root of 3. 12 times the square root of 3 equals the square root of 432. You can use your calculator and check it if you want, but I'm pretty sure it's right. Okay? Good, let's look at there. Let's see if there's another one. Oh, wait a minute. Did I skip one? That was example 3. Oh, I skipped example 2. Okay, well, here we go. Don't worry about it. Don't worry about it. Okay? Now, this one's already outside the radical. We're going to remember that. But let's break down this. Okay? This is root 9 times root 10. This is root 3 times root 3 times, let's see, that's root 2 times root 5. Okay? Now, let's write down what we've got. We've got 9, remember, times root 2 times root 3 times root 3 times root 5. Okay, do I have any pairs? I do. Right there. So now it's 9 times root 2. Well, you know what? I'm going to put that 3 in front now. 9 times 3, right? Times root 2 times root 5. Okay, well, let's multiply the things that we can. I'm going to multiply the whole numbers here, 27, and then I'm going to multiply the radicals back together because I can't reduce them anymore, and I just get root 10. So 27 times the square root of 10 is equal to 9 times the square root of 90. Okay, I can't simplify that root 10 anymore. I'm sorry I skipped that, guys. I don't know how that happened, but there you go. There you go. So now we've done 1, 2, and 3. Let's look at 4. And 5. Okay, so we got 2 more to do. That's all right. Okay, remember, here's 5. We'll remember it at the end. I know that 10 goes into it, right? 10, square root of 10 times the square root of 205. Okay, so then this is the square root of 2 times the square root of 5. Good. This one is the square root of 5 times the square root of, I don't know, 41. Is that right? 5 times 41? Sure. Okay. All right, so that's done, and 41's prime, so I can't break it down. So now I've got 5, right, times root 2 times root 5 times root 5 times root 41. Okay? There's a pair, so now it's 5 times 5 times root 2 times root 41. That's going to give me 25 times the square root of 82. Done. Simplify as much as I can, just like reducing fractions. All right, every time if I can reduce a radical, I'm going to reduce that radical. All right, that's good. One last one to do. Let's see. Easy, easy. Approximate each square root to the nearest tenth. Okay, they want us to use our calculator. Anytime it says approximate, that means use your calculator. All right, so this is easy. I know it's going to be negative, so don't mess around with that. Just find out what the square root of 4,800 is using your calculator, and then stick the negative out front. So, all right, square root 4800, enter, and it says to the nearest tenth. Well, I'm going to show you what I've got on my calculator. I got 69.2820323. Of course, it goes on forever and never repeats. But they want us to round it to the nearest tenth. So that means I'm going to put a gate around my number that's in the 10th spot. And I'm going to look at the number outside the door, get rid of this, third graders. I'm sorry, I'm just telling you what I would tell a third grader if I'm rounding. The only thing, I don't care what's back here. The only number I look at is the one outside the gate. And if it's 5 or bigger, it gets to ride the ride. So this goes up to negative 69, or rounds to negative 69.3. Okay? I'm curious. I'm just curious. If I square 69.3, I'm wondering how close it's going to get me to 4,800. If I square 69.3, it gets me to 4802.49. Okay? Pretty close. It's off because I rounded. Okay, that's it. Guys, that's all you need to know. Okay? And how to simplify radicals. Sometimes you may see them inside of fractions. That's okay. You simplify them and cancel out, reduce, multiply whatever you can at the end, and you're good to go. All right? Great job, guys, and I'll see you in class tomorrow.